Hello, this is Paul from Tech. In this lecture, we're going to find the arc length of a parametric curve using calculus. And here is the parametric curve. And the parameter t is between alpha and beta. So the arc length between these 2 points at the beginning is t equals alpha. At the end, t equals beta. What is the total length of the arc? So remember this, the basic integration, right? L is all the ds added together. And what is ds? Okay, we know ds is this. Okay, however, we cannot directly find the dx or dy. What do we do? Dx is described by dt, right? That means this divided by dt and then times dt outside, divided by dt times outside dt. Or you can say if we plug dt go inside the square root, and then is dt square, right? And the cancel dt square goes to dx square. Cancel dt square goes to dy square. So exactly this is what? Or this term is ds. Okay. Or this term is ds. The limit, of course, is for the parameter t. That's from alpha to t. Okay. It's from alpha to beta. From the smaller number to the bigger number, and then definitely this integral is positive. Okay, that give you one example. So how to use this formula? The formula is simple, just ds to integration, right? Okay, so here are the questions. We still deal with, okay, we still going to deal with the cycloid. Okay, to one arc, which means theta between 0 and 2 pi. The x and the y is this formula, and then we're going to find what is the arc length. And we use the formula first, right? So what the formula? How about here? The formula L equals this integration. Okay, I directly go to theta. Theta is go from 0 to 2 pi. And here ds. How to find the ds? Ds, remember, is this big term. Okay, and ds, this dx, right? So we go to dx over d, and the t is not the parameter. The parameter is theta, so d theta, and the square plus dy d theta square times d theta. See, that's ds. Okay, that's the simple formula for us. This is the formula. Okay, so now what do we need to do? We just do calculation, plug the derivative in. So what is the derivative for? Let me put it here. 0 to 2 pi. Okay, a little bit longer this time. What is x take a derivative to theta, which means this term. R is still there, and that's 1. So here take a derivative. 1 minus cosine theta, right? Square. See, that's dx d theta, the same. What's the dy? Dy, this goes to 0, this goes to sine, right? Okay, so what do we have? We have, let's tell you this, r times sine theta square. Okay, so that's all we plug the in and then take a derivative. No, and then do integration about theta. Look, it's complicated, but don't worry. So this we can simplify. Okay. If we're going to simplify, that means this perfect square, this is a perfect square, and the sine square, cosine square added together equals 1. That's the Pythagorean, all right? We use. After we simplify, we have this. I directly give you. So r square, take out is r. R affected out, put here. That's r. And then is 0 to 2 pi. Okay, here we use the Pythagorean. After the simplify, what do I get? I get this 2 times 1 minus cosine theta, and that's all. See, super easy, right? Now it's super easy. But this looks easy, but it's not so easy. Okay, so we need to deal with it because that's square root. How to take this square root out? So 1 minus cosine theta, this is sum. So double angle, do you remember this? Because double, if I put it here. And this term we can simplify using the double angle. You learned it in trigonometry. double angle identity. It is the 1 minus cosine theta equals what? Equals 2 times square, right? Square of sine at theta over 2. Okay, so this one, or you say cosine theta equals 1 minus 2 times sine at the half angle. Okay, this we call the double angle. If we plug this in, see, this take a square root, definitely we can simplify. Okay, what do we have? And this 2 and this 2 is 4, right? Take out is 2 again. So we have 2 times r. So I have 2 times r per here, and then 0 to 2 pi. And this goes to this take square root. Okay, sine theta over 2. Theta belongs to 0 to 2 pi. So half of theta belongs to 0 to half pi. Or the sign is positive. I mean, this take a square root directly. We have sine theta over 2 and theta. See, okay, now good. We successfully deal with the square root. So all we need to do now is do simple calculation, right? So this we know what is the antiderivative, which means this. Be careful about this coefficient. So we do have a negative cosine. Okay, it goes to sine, and this is 1/2 over 1/2 is times 2, and then cosine theta over 2. Okay, good. This is the antiderivative, and that is fundamental. And the plug in to calculation, what do we have? We have 8 times r. Okay, that's all. Thank you.